Okay, it should start, right? This should start. So, okay. I find something quite interesting today is that GDC finally adds Loongarch support. Last time I make a video about Loongarch, but that video was that I forgot to enable my microphone, and I'm sorry to say that, so I'm going to create that again. Yeah, this should have audio input. So we now have Loongarch update for Loongarch pod. So what is Loongarch? And that's exactly what I talk about. So GDC now supports Loongarch. It merged the support with Loongarch, and we need to understand. Here's something I want to talk about today. Just Loongarch. Okay. So Loongarch is an architecture. It's a new architecture. Why do you need Loongarch? Okay, so Loongarch is an ISA. It's an instruction set architecture. It's not a real machine. It's just called ISA. ISA is defining a machine language, and it's assembly for particular types of CPU. So you have x86 6 ARM, you have x86 64, you have ARM, you have whatever you have. Now they are all ISA. So ISA is a machine language, and it has its own assembly. So it also the ISA also defines other things like interrupts, traps, syscalls, ABIs, whatever, virtual memory layout or something like that. So ISA is basically a machine language plus some other operating system kernel for features. I think that's. Yeah, you can define more, but in general, you can just think of ISA like something like this. So then the question is that why do we need why they create this Loongarch architecture? Why it has been merged into both GCC, being utils, GCC and Linux kernel. Now we have the GDC port of Loongarch. Okay, so Loongarch. Its background is that MIPS is obsolete. MIPS is obsolete, whatever. The Langsang, which is the company where they will have a long history of maintaining MIPS, they produce a lot of MIPS chips. Since MIPS is obsolete and the company of MIPS have just basically deprecated and removed the support. They no longer support their own ISA. It becomes completely obsolete. Nobody is using it, or probably some old hardware, but in general, very few people are still using the ISA. So now we have, so the Langsang, they have a history of maintaining MIPS. They're not just using MIPS; they're also maintaining MIPS for a lot of software. They add a lot of features to MIPS. So MIPS has a long history of being maintained by Langsang right now, despite them owned by the MIPS company. The Langsang has a very long history of maintaining it. Okay. Now you might ask why, if they have a long history of maintaining the MIPS, the Chinese company, why would they just not continue using MIPS or just buy MIPS? Well, they actually tried to buy MIPS, right? Other Chinese companies are trying to purchase MIPS back in 2017. But if you look at what Donald Trump did, is that Donald Trump blocked Chinese company for purchasing MIPS. Okay. Purchasing block Chinese companies buy MIPS, right? Whatever. I think whatever, in 2017, last time I have that news here, I can show you here. Yeah, whatever. So whatever the case, okay. Is this? No, probably not. For in general, we're now living basically a trade war between U.S. and China, and Donald Trump back in 2017 is blocking Chinese from buying it. Even that ISA is completely obsolete, right? ISA is not something has a lot of technology. It's not like putting on chips. It's just defining a language. But even with that, the U.S. believe that it's a critical U.S. technology. They are not going to allow Chinese companies to purchase in MIPS architecture. Okay, so because of that, since they're not going to use MIPS, but the MIPS is obsolete, and U.S. doesn't allow Chinese companies to buy it. And plus, Longsong, since I have said they're maintaining MIPS, right? They also create a bunch of MIPS extensions. They need those extensions for their own demand because the MIPS ISA itself doesn't allow too much things to extend itself. They have basically running off the space for instructions to continue adding instructions to MIPS. Now the feature is that if you look at what this architecture is called Loongarch, the Loongarch, the ISA is like MIPS. It has no flags at all. It has no flags. But it leaves space for extensions, so it has a lot of instruction space for extensions. That's what I heard from their own presentations. They also have a very interesting feature is that they provide extensions for x86 and ARM emulation, so you can run x86 and ARM and a lot of other ISA programs itself by using this hardware emulation. They have entire video talking about why they are doing this, why they are doing that, but I just want to talk about this feature by myself. If you want to go that, you can go watch their video, but their video is a Chinese video. If you don't know Chinese, you're probably not going to understand that. But in general, the feature is like MIPS. They have no flags, and it leaves space for extensions like MIPS, and has provide extensions for emulation. So they provide emulators, some emulation mechanism for running x86 ARM programs. It's not guaranteed to run that. It just provides an extension. Right? Even ARM provides similar extension. So it's basically how their ISA is designed here. It doesn't mean if you buy a Loongarch chips, you will have that emulation. No. Okay, it just that provide the ISA itself allows extensions for emulation. Now the question of a lot of people are saying why not use RISC-V? Why? If your goal is to U.S. company preventing U.S. company or blocking you for using it, why not just use RISC-V, right? My short answer to your question is that RISC-V is a bad ISA. It's a terrible ISA. Let me see whether okay, it's working. So the short answer is that RISC-V is a terrible architecture. Now you might ask, why do I say that? I just use this SHA-512 example. If you just use RISC-V as to compile a SHA-512, I think I did make that video before, is that it generates, since it does not support ROR and byte or some trivial instructions like that. All they are doing is emulating with shifting, with the L shift, right? And now you have 1,800, just nearly 2,000 instructions if you count the numbers of tables. So it's a terrible architecture. This architecture is definitely terrible by default. Although they provide extensions, but the problem is that when they provide extensions, you have this ecosystem that's very complicated, right? If you want to run a program that's going to run a lot of RISC-V machines, you're not going to do that because the ecosystem is very complicated. And also RISC-V, they don't control RISC-V, right? They cannot easily adding extensions for RISC-V for their own demand. They have a demand for continuing supporting MIPS-like program, and they also support their old extensions. They cannot do that with the RISC-V. That's exactly why they are using this they are not using this architecture. So if we compare RISC-V to Longarch, just both SHA-512, we can see Longarch only generates 1,241 instructions of Longarch versus Longarch 64 versus 1,860 of RISC-V. Okay. Now, what about extensions? I don't think even extension fix the problem. Right? You have the extension, you have to give a flags, and you probably get much fewer instructions, but still a little more instructions here. Well, it doesn't matter, but you can think it's very bad, right? You have so many years of optimizing RISC-V compared to Longarch, which is basically 2 months of Longarch development. Now you have more instructions, 600 more, plus you also have function calls here, dude. You have function calls for things like byte swap. That's a huge issue. If you try to run RISC-V program, it's going to run very slow, not unportable code. So RISC-V is terrible architecture. It's just a general answer. That's exactly why RISC-V cannot replace x86 and ARM in any form. It's bad. The long answer is, like I said, the ecosystem is complicated. You have this extension, that extension. You have even multiplication and division are extensions, right? You might on a RISC-V machine that doesn't have multiplication, it doesn't have division, which is ridiculous, right? Their goal is saying, hey, we're gonna running on this low-end device that doesn't provide those instructions. But that is also a very terrible argument, right? You can argue that we have some machines that even the char bytes are not 8, right? You can look at a bunch of embedded devices, their char bytes are 16. Since that will save space for saving the pointers. But RISC-V doesn't support that either. So RISC-V is nowhere like the ecosystem is complicated, and it's complicated for no reason. And that's exactly RISC-V is a terrible architecture. And second is that they cannot easily add extensions for RISC-V. Like I said, before they add a lot of extensions to MIPS, right? But they are not quite like to do that. They would rather just create their own ISA to satisfy their own demand instead of just adding instructions, right? Because creating an ISA isn't that hard. It's not a hard problem, right? Now why not just creating a new ISA? So the entire logic makes sense. It's not like people saying why they're not using RISC-V. It's just RISC-V. No, RISC-V is a terrible architecture. That's the reason. So what's the current target audience? The current audience is very similar. It's just for Chinese government, the Communist Party, and the People's Liberation Army, and also state-owned enterprises, public schools, hospitals, something like that. Just public services, right? They're that's their target audience. Particularly, we are at the basically the new Cold War, right, between U.S. and China, or China and Russia, right? And maybe this architecture will also be used in Russia, something like that. But in general, the current target is for those companies. Now, there are some people saying, well, that be commercial usage. They would like to see a commercial usage for this new architecture because they really want a competition with ARM and Intel, whatever. We're gonna see. I don't think that would be possible, but maybe they will happen. But you shouldn't expect that. But we know their current audience are basically the Chinese government, right? Communist Party. The PRA, so it does make sense, right? They can still make a good sale, they still earn money, they can still maintain their company by selling this ISA. And what the current situation is that, okay, so this is exactly what today I'm just in the exactly what I want to show here. Change, I'm gonna today. Yes, okay. So their support bootloader. Based on the news here, I know the bootloader hasn't been supported. They haven't committed supported for bootloader VUEFI thing. But Linux kernel, yes, the Linux kernel already supports LARC. Bingutils GDB, which is the AR, I'm gonna show you later. So Bingutils GDB, GCC, and glibc, they have all get supported. So you can now get a LARC architecture, torchain right now, just by using the normal Linux torch. You just get those source code, you can get a torchain. So let's just start to build a torchain, okay? Let's start a torchain. Let's start a torchain. And the first thing I'm gonna do is you reflush it. So, okay, before I'm doing that, I wanna fix a bug in the GCC. So, is that GCC? If you do Canadian compilation for Windows, they're not going to generate the correct dynamic libraries. They'll override each other since the scripts are wrong. So what I'm going to do is I'm going to go to the file system to use this GCC x86 fix. No. Okay, just replace the file, replace it with another text, right? Compile it. I have already compiled it. Let's just compile it again. Use Go linker. We can use mark native. Static. Yeah. Done. Yeah. 14 kilobytes. GCC, we go GCC here. We go GCC and let it fix the problem. That's it. That's nothing else. Okay, done. So it fixed the issues for that. We can just check here GCC. Yeah, it's fixed right now. We can see the data already changed. And we won't be able to get anything. So we're gonna get a LARC torchain right now. I think I did have LARC. Yeah, well, I did have LARC build before. Let's just do it again, okay? So I'm gonna show how to get a torchain. So first thing, we're gonna clone the Bingutils GDB, right? We clone it. We set its prefix. Okay, set its prefix to a prefix. So first we're gonna do is setting target. Target is LARC 64. Linux kernel, right? You have architecture. This architecture. This is the operating system kernel. This is the glibc, the libc word, right? Target. Then we have prefix. Prefix equals. Yeah, I just call it cross path. Cross path is actually this one. Right, you can just set home, whatever you want. Just set a torchain to install that. For me, I would install something like here. Okay, that's what we need. What we also need is, yeah, we go here, we set, no, we're not with Python, with Python 3. We're not with Python, okay. Let me just delete all of them. Let's just go off them. Delete all of them. Let's just clean it. So we go here, we print it out. No. Now first thing we're gonna do is we set the export. We export the target here. We set a prefix. Now, what's that? Yeah, what's this? We can just do something like this because it's going to show us something. Then we replace this target with target, prefix with prefix. So it's going to install here. Okay, it's going to install here. Let's just echo what's the result here. Yeah, here's the thing. Let's just start. Let's get started. So yeah, now we can see here target the whole system and build system are our kernel system, and the target system is the Loongarch Linux kernel, right? Now we start. Give us 12 threads. We're gonna build it. No people here. Hey, just call that Java lab here. Just let me call some people. Yeah, let's just go when the. Yeah, I wanna show you the blog Chinese buys MIPS. Chinese company buys MIPS. Sell MIPS, right? And they block it. I do remember correctly. They blocked it. They blocked cracking trees. National security, right? Oh yeah. Sell Donald Trump. Blocked, yeah. Donald Trump blocked that. They don't allow China to purchase MIPS, right? It's critical whatever technology, right? Technology. Not this one. They just talk about MIPS. Yeah, I think it's probably nearly done. No, okay. So now we have. Oh, here's another thing. You should also set export path equals prefix. No, path. You should also export that. I think I did. Whether I did or not. Yeah, packet prefix.bin. Okay, because our new GCC cross compiler installed here, right? Then we need to also put other path here. If you say something wrong, you can just restart this terminal and it will do it correctly. So we do make install strip, right? J. Make and make install make J and make install strip J. You can also give it a thread, something like that. Now we have the AR. Yeah, we don't have the AR. We have GDB, right? We have GDB. Just the GDB we compile and build. Just build. So now we start to build GCC. So when we build GCC, we need to do two things. We need to build it for twice. Okay. So we need to have a GCC phase 1 and GCC phase 2. Okay. Because we need the first GCC with the freestanding one. It doesn't use anything. It's just to produce the compiler. Okay. It doesn't. Yeah, we need that one, that kind of one. It can only build programs, but it cannot do. Or it can only build things like. It cannot build actual programs. It doesn't have libraries, but it can compile Loongarch programs, right? Okay, let me show you here. We can, after we do something like this, each time we do something, we can just pour it to see it again. Pour the architecture. Oh, remember, you need to ensure your GCC is itself, the native GCC is new enough, because if your GCC is not new enough, you're probably not going to get the cross compiler work. Now we have a very new GCC. I'm not going to build again. Now we have GCC. Disable W error. Target equals target. Prefix equals prefix. Then we also need enable languages. C++. We don't need any other languages. We only need C and C++. now we also need disable host the libstdcxx without headers. With newlib, I don't think we need with newlib. What we need is disable hosted libstdc++ and without headers. Oh, we also need disable threads. We don't need threads. Disable shared. We don't need shared libraries. For the first phase, we will build it later, but in the first phase, we will not use them. I always don't remember those things because just by maybe they're gonna miss something. Let me just check it again. Disable threads, disable shared. Is that GCC disable thread? If you don't remember that, you can go Linux from scratch. It will tell us what kind of flags we're gonna use. They'll give us a lot of flags, but we don't actually need that kind of flags here. You can see they also disable other libraries. We don't actually need to do that, to be honest. What we need is without shared, disable shared and disable thread. I think that's enough. Do we need to enable multilib? I think the multilib should be enabled by default. We can go after it later. GCC, yeah. Yeah, you should be able to detect long arc GDB, long arc, yeah, strip. AR, right? AR, run lib. Yes, strip. Yeah, it has detected all our torches. Now we can start to build that. C enable language C and C++. Yeah. Now we're gonna do. We don't do this. Okay, we do is make all target libgcc. We only need libgcc for thread. Yeah, all target libgcc. Yeah. Now we can wait a little while. Now it starts to create a cross compiler. We need the first cross compiler to build glibc, then get a full-on compiler by ourselves. Cross compiler. Then go back. We are gonna using Windows compiler to get a Windows hosted GCC. Okay. Canadian compilation is, I'm going to finally do Canadian compilation. Canadian compilation means create compilers for another machine, create compilers that run on another machine. For example, I have this x86 64 Ubuntu Linux GNU G++. Right. I get this cross compiler. You can build. This is Windows, okay? I can cross compile Linux programs on Windows, right? But I cannot easily create that compiler, or even G++ itself. It's not created on Windows. It's not I just create that on Windows. It's not. This compiler itself is created on Linux, okay? That is Canadian compilation. Is that I'm creating compilers for another machine. I'm not creating for this machine, for the build machine, okay? A Chinese company. I don't actually care that much about spyware, dude. You always get spied, right? The only thing is that whether they want to spy you or not, right? You live in digital world. You use these services. Even using Linux, you're not going to solve problems. You're still going to use these Google services. You're going to entire internet is running on Google, right? You're going to use these Google services. You're going to use Google search engine. Everything you did is leaking your information. So I actually don't care that much about spyware because you always get spyware, no matter what you want. Yeah, Chinese spy, whatever. They just believe, it's quite ridiculous. They believe that an ISA is a critical US technology. It's not, right? ISA is not a critical technology. Anyone can just, with college, computer science, degree, they can have that, they can create an ISA. The only problem is that whether you can create it rational or not. Something like RISC-V is clearly not something quite good, right? I'm sad RISC-V is not good. Since GDPC just creates this new architecture today, I'm gonna just create that architecture. Is anyone still in the chat? Anyone in the chat? No one is saying anything. Yeah. Now we get it's cross compiler. We get cross compiler. We're gonna build it will continue to build libgcc. We need libgcc here. Now finally we are going to get a Windows hosted cross torch that could cross compile Loongarch programs. Okay, that's our final goal here. Now what we're doing right now is on Linux. It's not on Windows. Despite I'm running on Windows, it's actually Linux. You can see it's Linux. Okay, it's a Linux machine. I'm just remotely using SSH to connect to that Linux machine. Hi. Yeah. So I'm gonna show. Yeah. So now it's starting to create a machine. So it's quite frustrating. The libs to C++, you cannot actually create libs to C++ freestanding one. See, in theory, we should also create C++ freestanding one, but we don't. We cannot, right? So which is quite annoying. Now we're gonna install the compiler runtime library and the GCC with it. Oh, they have the looks like they do have the how many multilibs they have. We go there and check it later. So now we have this Loongarch 64 Linux GNU G++. Okay, this is G++ here. We get that thread, we get that the torsion. We need that torsion to build GDBC, but I'm going to just check it's installed here. Now we don't have any C++ standard library. We don't have. The only thing we have here is the compiler itself, and the they do have the multilibs here. It's LP64D. We don't know, right? We don't know what's if I remember correctly, they are both the same. They're exactly the same. Even they are saying they are all the same. That's exactly the same for the Loongarch currently. But we don't know what is their thing here. We can go here and go GDBC, go to GCC phase 1. Yeah, they have the base and no base. Go here, go make fire. It's gonna show us what is the flags here. It has no flags, looks like. So this should be the default one. They also have this base and LP. They also have a makefire. This one should have another flag here. Target Chronicle. What's the CPU? Double size. Do they have any flags here? Yeah, they should. Yeah, MABI equals LP64D. But I don't think they have a suffix for that. No, they don't. Whatever, just two multilibs, two ABI. Okay. Now we start to build GDBC. Okay, but GDBC we need several things here. We need a installation here, which we're gonna first install here. We're gonna change that, we modify that, and go back to copy some files. And we're gonna put GDBC. They have the LP64D, right? LP64D and GDBC. We're gonna build this multilib here. Now, before we're doing that, we also need to go to the Linux kernel here. We're gonna go to Linux kernel. We can just pour that because yeah, while we build something, some new changes have been pushed to GCC and all the torches here. That's exactly why I'm just doing that. You can just always get the latest one. Okay. So we're gonna go to this is Linux kernel. Okay, this is Linux kernel. We have the Linux kernel. We're gonna make headers install Loongarch. long64 install HDR path. Do they have any questions? Oh, doesn't matter. You can just anything. You can just ask me here. HDR path. This means we're gonna install the headers to somewhere. We're gonna install. Right, we're gonna install the place where the Loongarch 64 Linux GNU Loongarch 64 Linux GNU. We're gonna install here. This is the first place. No, we don't have Loongarch 64. It is just Loongarch. Okay, it's not Loongarch 64. Now we install headers here. We go here. We go here, and we're gonna check that. Building GDBC is the most annoying part. Not annoying. I mean, it's something you should be very careful, right? Because if you're doing this wrong, you're not going to get it. Now we have the Linux kernel header files. So those header files are provided by Linux because GDBC needs these headers. Now we start to build GDBC. So we can start to first build the GDBC. Okay. The better things we're gonna do is I'm gonna go into installation. I'm gonna create a Canadian here. Everything will first install the Canadian and we'll copy it to cross. Then we're gonna copy in the cross and copy it back. So we're gonna first install the headers here. Install Linux kernel headers also here. Linux kernel headers. We need to put a home directory here. Yeah, it should. Yeah. Now we have include the Linux kernel headers. Go GDBC LP64D. Go GDBC. Put CC equals Loongarch 64 Linux GNU GCC. What flag I'm gonna put here? We're gonna put the MABI. We're gonna get a C here. MABI equals RP64D. Also for the C++ compiler, we're gonna put both C compiler and C++ compiler to give them a flags. 64D, not GCC, but G++. Okay. Config, disable NLS, disable WError. Then we're gonna install it here, install the installation here, but we're gonna put it host, not target but host. Okay. Prefix equals LP64D. But here you don't have home, right? With home directory, we need to put a home here. Yeah. Doesn't matter as long as the thing here could work. We don't actually care that much. We're gonna make J. Now it's starting building GDBC. Anyone here? No one is here right now. Let me check this my streaming. Yeah, 2 people are watching here right now. Okay. Thank you. Yeah. GDBC provides things like stdio, whatever, also the POSIX header files and the POSIX features. They are in the GDBC, the POSIX. Yeah, the GNU libc. Okay, now we get it. We cannot actually do this. There's no install strip. The only thing you could do is only make install. We're gonna strip it later. Okay, this first one. We go GDBC. Then we don't need that flag anymore. What we only need is is the default, is the base one, whatever. Right, we can just call it normal, whatever. It doesn't matter. Okay. And we don't need those flags at all. Since we're not putting any flags, we don't need to put that. The compiler could know. Here we're using longarch 64 Linux GCC. Could run G++, right? Yeah. Install strip, and in strip means stripping the binary, because if you just install, they will not strip your binary. The binary will contain a bunch of debugging information and other part. It will make binary very large. So after stripping, those binaries will be stripped out, and those debugging information will be stripped out. Since GDBC itself doesn't support making install strip, we need to, if you want to strip, I'm going to strip it later, just to show you the difference here. Okay. Yeah, GDBC. Yeah, we're building GDBC. Yeah, done. That makes sense. Now here's coming the most tricky part. We have to be very careful. Okay, very careful here. Now, so what we are going to do is that we go to for example, we go to the LP64D, right? They provide a bin. They also provide things like locale, whatever. But we need to remember, none of those tools that can be used because they are using a cross compiler to build them. They cannot. This is running on the host. If you have a longarch machine, if you just port them to that machine, you can run those executable on that machine. Those tools are not native tools. They are running on the longarch. We are not going to include that. I'm not going to do that. Okay, you should just use the tool on your if you have the longarch Linux distribution, you should just use the tools provided by this distribution. Unless you're creating your own Linux distribution. So we can go here using LVM obj dump. If you don't know what the header files here, we can just check any of them to see what's going. Yeah, we can see the LVM obj dump tell us is the longarch architecture. It's not running our x86 because our machine is x86, right? We have our running x86 64 Linux kernel. That's our native torch. When native torch is x86 Linux kernel, not longarch, right? So now we have the stripping here, the libc, and they include something like stdio are all installed here. Okay. Now what we are going to do is that we're going to copy all the LP64D. Be very careful doing so. Okay. Copy its lib. Okay, copy its lib to just first copy its include file to the Canadian directory. Also copy the normal include file to that directory. Next, going to come in with the tricky part is that where the LP64D is going to be installed. I have a native tutorial. Can I just use that example? Because I don't remember that either. Where did I install that? LP64D. Probably it's in the base directory. I think the correct answer should be in the Canadian base directory. If we create a directory called lib, it should be in the base here. But actually, they are exactly the same, so it doesn't really matter here. We can actually strip it out. We don't even care about that. So yeah, should be lib then provide a directory called base. I think it should be that case because they don't. That's not their well document. I don't think they're well documented where the directories are located. LP64D. We're gonna copy libs here. Okay. Now we're gonna move LP64D to move the lib to LP64D. For things like, we also have the normal part, which is normal plus lib. Now we're putting lib here. Just put normal part in the Canadian. Now we have all the headers. So now we gotta start strip all the everything in this directory. We first go here, stripping. We're gonna call longarch64 Linux GNU strip unneeded. Strip everything and all the strip com.strip. Yeah. Yeah. We have stripped everything. We also need to strip those things here. Okay, here comes another tricky thing here. We have the lib here, right? So it's just ridiculous here. We go, for example, glibc libc.so. See this bunch of one, right? Now here's they're using the absolute path. Okay, we don't want absolute path, we want relative path, so we just remove it here. Do they have other things here? We're probably gonna check. But no, this, yeah. It should be only that, if it is doing right. Yeah, it doesn't have. Even ISCC6, you also need to change libm. What do we change? Oh, lib. Now we're not changing these things in the base, right? Oh, they do have libm, but libm is static linking. They're not dynamic linking the libm. So we don't need to care here. Elf longarch. Maybe there's something wrong here. I don't know, but it doesn't look wrong. Yeah. Now we have Canadian. So normally I would do a cross because Canadian and cross are not the same, but for longarch it looks like this is the same. So what we're gonna do is I will copy all the files to the. Let me just check the prefix right here. We're gonna copy all the files to the prefix .target /target. Yep. Yeah, now we can go back to the cross compiler to see whether it installed correctly. Yeah, now we have all the headers and all the libs here. Now we're gonna start to build GCC phase 2. Now we have the stdio here. We can use that to build things here, right now. Now, if you don't believe that we can create something like stdio, it's not working right now. And we get rid of stdio, it should work right now. Hello world, right? We cannot do C++ because C++ we haven't installed C++ standard library. We're gonna build it later. That's exactly what we're gonna do. So we can just, for example, create an a.c 03 or 03 whatever. Yeah. Now we have the A. We cannot run it because it's on another architecture, but we can run with longarch64 readelf for obj dump, right? We just use obj dump or use just LLVM obj dump. Yeah, we have the longarch here. If we go for MABI LP64D, let me see whether that works. Yeah, it also works. Yeah, it also works, no problem. So now we start to build GCC phase 2. Phase 2. We have the long arc 64 Linux GNU class. We're gonna change it to something else. We don't change prefix. We need to change something else, like disable libstd C++ verbals. No, without headers. Now we enable those things right now. But if you remember correctly, we need some error or some other flags. Let me check our native torture or other cross torture. Yeah, the only thing we didn't put here, we can put this here. If we want to support LVM lib C++, we can put it. We can give it the flags to support LVM lib C++. So we're gonna do is a long arc 64 Linux gonna put just put here. Okay, include C++ v1. Yeah, that's it. That's everything what we need. Yeah, we just go here, go start. After we build that, we get a compiler, but we're not fully finished. We still need to build something like GMP, whatever, install GMP, for example. If we want to get a native long arc compiler, Torchen, for example. It's quite good, right? I cannot see any comments. I don't know. Is some comments here? Elf6. Are you still here? Elf6? Elf6? Anyone here? Yeah. Oh. Sorry about that. I think probably I can change the lag here. Okay, then we have some latency. Okay. Yeah, this I think it's gonna take another 10 minutes. We're gonna at most 10 minutes. I don't think it would even take probably 5 minutes. This will finish. Then we'll get a long arc cross compiler. But this compiler is running on Linux, right? It's not running on Windows. The final thing we're gonna do is that we're gonna make it running on Windows. First, I'm gonna install the local version with it. Local. I already have one, but I'm not going to. I'm just gonna delete it. No, we don't have that. Yeah, I did put in the put the long arc in the. You can see in the environmental variable. Okay, it doesn't matter. Okay, put it upper, no problem. Because finally, what we want to get is that, a long arc torsion, that cross torsion that could run on Windows, right? Well, now you might ask why, right? You may ask why. Suppose you're not using this Canadian compilation. What are you going to do to get for example, Linux cross compiler that works on Windows? Do you know how to do that? In your imaginary part, for example, you think how it's going to work that way. No, right? Because the entire GCC scripts does not even work on Windows, right? You might say, I never used cross compiler before, right? Okay. But even native one, if you want to get a native GCC that works on Windows, what are you gonna do with it? A lot of people just build it with MySys2 or something like that, right? But if you try to build the GCC itself, it's still going to be very hard. You're gonna add a lot of patches, whatever, just to ensure that you can just native compile or something, right? Because on Windows, if you try to use GCC to create a GCC compiler, it's not easy, right? Despite GCC is very good on Windows, to build a GCC on Windows is very hard. You better just do something on Linux and using this Canadian compilation thing to get it work on Linux or get it work on Windows. That's something I'm gonna later show in here. Let me see. Probably I did have a Trojan installed before. Do I have Loongarch? No Loongarch. So we can start to create a Loongarch 64 Linux right now. Then create another subdirectory called Loongarch 64 Linux. So we just copy the Canadian directory we just created here. Not here, but GCC build native Loongarch 64 Linux GNU. We have the installation, we have the Canadian, right? We just copy the Canadian directory to here, to Loongarch 64 Linux GNU to here. Oh, sorry about that. Yeah, just so we can skip that part later. Yep. Here should be the thing here. Yeah. Now we have the include header files and the div here. Now you can see it's a bunch of symbolic link, right? We should just compress them with something like tar to ensure those shared linking doesn't break. Okay, that's extremely important. Okay. On Windows. Okay, now we have the cross-chain here. Yeah, we have the cross compiler that works on Linux. Now we can do something like IOStream or even FastIO could work right now. Okay, try IOStream, then try FastIO. Okay, cout hello world. Right. Now we have Loongarch 64 Linux G++ A8cc. Right. We can use all the flags we like, but the only thing we cannot do is mmark native. No, you're not running on native compiler, right? No Go linker, there's no Go linker support. Yeah, does it support LLD? Does LLD support that? LLD, no, not LTO. Does LLD support that? No, no LLD. Okay, no LLD either. So just use GNU normal linker. Now we have the Loongarch versions of Hello World using the C+ IOStream. Okay, right. Now what about FastIO? We can also try FastIO, for example. FastIO doesn't need compilation. We just put a FastIO here, right? Now print it. Just print Hello World. Loongarch 64 Linux GNU. But we need to include headers, right? FastIO is installed somewhere else. It's installed in the home.include libraries. Libraries on FastIO.include. Yeah. Now it's another thing that works for FastIO. Yeah. So this is FastIO versions of Hello World on Loongarch. No problem. Now we start to do GCC phase 2, or not phase 2. We're gonna create Windows compiler. So we're gonna create Windows compiler by doing this. Delete that. Let's just assume we never did that, okay? Because I did it before. Now we're gonna still do another refresh here to ensure that there's something, everything we get is up to date, right? Make dial 64 Linux. Now, to do that, you need to first ensure you have this, you have already created the GCC cross compiler, the Win32 versions of compiler, right? The x86 64 MinGW632 G++. Because now we are going to do is that GCC will use 3 compilers at once to create the new compiler. We have our native one, we have the x86 64 Windows W64 MinGW32 plus the Loongarch 64 Linux. It will use 3 toolchains at once. Right. I'm going to go bin utils. Now, prefix, like our prefix is here. Now we're going to change prefix to somewhere else because we are putting another compiler here. It's still here, but prefix is no longer prefix here. We can just use host prefix instead of just use that prefix. Okay. So we're going to do is go toolchains x86 64 MinGW62. I love to name the name like something like this to ensure it doesn't can't get conflict from something like that. Yeah, we have the Loongarch in that Loongarch. It's easy Loongarch. We just do that. Yeah, no. This something quite ridiculous is that they put a backslash here, which is quite annoying. Now we just put the bin utils here, but we cannot do with Python 3. There's no Python on Windows, so we don't put Python 3. And we're gonna put a host here. Okay. Host. We need to export host. Equals host. The prefix is no longer prefix, it's the host prefix here. So we export here, and we do export here. And now we start to just do this. Let's just check. Okay, the build system is Linux kernel. The host system is Windows MinGW32. The target system is Loongarch. A cross compiler is exactly the same as a native compiler, to be honest. They have basically the same directory, the installed directory in the same places. That's it. Nothing too fancy. It just have a prefix here. So if you see something like G++, okay, it doesn't have any prefix here, right? It's just G++. It's a native one. If you see something like this, right? You have x86 Ubuntu Linux kernel G++. Then it's a cross compiler. The cross compiler has something triple with it. Okay, it's not client. Client doesn't work this way. Client is always using the target. It's always just only with one client, but it's the target. That's it. Target as this root. Okay. Maybe they're gonna support it later. I don't know. But now we are creating GCC and bin utils and G++ here. So it's now creating the Windows compiler. They're gonna work on Windows. I'm gonna show you later. Creating the toolchain part, whatever. Oh, not toolchain, but the assembler, linker, that kind of stuff. They're gonna work on Windows. Trade. No, we also have GDB, right? You can see GDB is here, right? GDB.exe, right? install strip, right? I've said we need to strip the binary. Yeah. See here, we have longarch64 linux.exe. This is the Windows binary. Okay. Now we're gonna create the GCC part. The GCC part. So we do the same thing, except putting a host here. Host equals host. Prefix equals host prefix. So we can just change this manually. It's also working. Change this native to just change it manually. Also works. Yeah. I didn't try to build a libc++. If you want to try, you can try that. But I'm just usually do that, but I don't like to try that. Maybe it's working, right? Maybe we can have a try later. Yeah. We just create the GCC here. You're gonna build everything again, or everything, okay? Not everything, just everything that will work on Windows, including the library with why? What the box is here? Looks like we probably encountered another bug. No such directory. LP thread. No LP thread. Okay, no LP thread. Oh, it's a bug. It's definitely a bug in the GCC. It's just a bug, right? They haven't fixed it properly. Yeah, they probably didn't fix the bug here. Where's that? Cannot put LP thread, GMP LP thread. LTO, yeah, LTO. So they did have the bug here, and they didn't put LP thread here. LP thread. I'm gonna report that bug. Config here. P thread. No, it shouldn't work this way, right? P thread locking. It still requires us to use P thread. What that shit here? No, use logs. This bug, it hasn't get fixed, you know. They didn't fix a bug here. I'm gonna report the bug again. It still hasn't fixed. It still has not yet fixed. Okay, we better just not put here. We better just, we have errors. We better put in a fire. Just do something like this. Okay. Yeah. It's not yet fixed. Maybe it's my fault. Let's just check everything. Oh, don't do something too crazy. AC log, change log, config.ac. I don't think it's the reason, you know. Oh, check out. Probably. Yeah, probably just was my bug. Not their problem. Oh, still that bug. Cannot find LPs. Just no LP thread, dude. There's no LP thread. Why do you put an LP thread here? Yeah, this had. It's just wrong, dude. It's just wrong. No, I don't have pthread logging. I'm sorry. I don't have pthread logging, and it's Windows, right? Windows doesn't have pthread logging. I need to test pthread h. Do I have pthread or h? It does have pthread or h. Yeah, I think the problem here is it probably detects pthread or h, but or just a placeholder. It just thinks here's a header, but actually you don't have that header, right? You don't have that header. So it shouldn't do that with Windows. Something quite ridiculous here. Extra target. Or it's target here. It should be host, right? Not target, right? It should be host. Why is target, right? It should be host, right? I think that's probably the reason. Yep. Now this should be host. Just tell them they should be host, not target. Yeah. Just tell them that here's a bug here. So yeah, that's it. No any other problems. Just a problem. It's just a recent bug, recent regression of GCC. Okay, I knew that bug, but they didn't fix it real correctly. They put it in a target here, but that's wrong. It should be host, not target. Okay. No. Let me change it. Change it to Loongarch 64 Linux GNU, for example, right? Save changes. Yeah, I just report that bug, and GCC will fix it later, just probably tomorrow, something like that. Now you can see he's not using cross compiler to create a compiler, right? When you do Canadian compilation, something like this, pretty Canadian cross, GCC will use 3 compilers at the same time. 3 compilers, native one, two cross, okay, maybe 1 or 2, but here we're using two cross compiler plus native compiler to create the compiler that works on Windows. the cross compiler that will work on some Windows. Yeah. UB3 Yeah. Before we are using x66, W64, Winjin W, right? Now we're using longarc 64. Longarc 64 Linux is going to build the library part. The library part. G++. Yeah, so using longarc to build the deep GCC and libstdc++. Yep, done. Install strip. Okay, finished. Now we have the torching. Yeah, we can go here and have a check. Not here, this native compiler. Yeah. Right, so we do tar cbr. We put in a tar pack. Yeah. Tar it. Put it here. Copy here. I've already added environmental variable here before, so we'll go here. Go here. Yeah, ensure we have already set the environmental variable in the past, right? I'm not going to do that again. So here's the thing here. Is we have the naming issues. They have the uppercase, lowercase here. We just call it auto rename. It should get fixed by GD in the Linux kernel, but they didn't. It's quite sad, you know. Yeah. Now we have longarc 64 Linux GNU G++. Okay. This runs on Windows. Let me just try compile something. For example, compile fastl. For example, hello world. Yeah. Working. Okay. You can see it's on Arc, right? This LLVM obj.terra system on Arc architecture. Oh, nobody uses Firefox, dude. Why not? Why is not losing? They lost Edge has now has 3 times more users than the Firefox have. You want to show that? I'm gonna show it here. Network market share. Net market share, right? Just go there, okay? It's shocking, you know. It's gonna be shocking. We go browser market share. This is browser market share. Oh, it doesn't seem quite bad. It's 7.48, right? This is the average. This is from 2019, dude. Let's just see what about today. See here, okay, dude, see here. And Edge now has 3 times more users than Firefox. And it's clearly growing if you look at the trend. Edge gains a lot of users. Firefox just keeps shrinking, right? Even by this year, they have lost 10% of the user base. So why is not just 6 months? Okay, they lost 10% of the user base just in this year, 6 months. Dude, you tell me they are not losers? Nobody is using it, dude. Don't use it. So, yeah. Now we create the compiler. See here, we have a compiler that compiles on Windows Linux. Yeah. So let's just try to see something. Is this actually Loongarch supports C+ exceptions? They already have the ABI that supports exceptions. No problem. This is with full-on support. Okay. I want to show the SHA example. That's my favorite example of freaking SHA. So now I just put the function here. Okay. Probably we need GNU flatten or something like that. Now I'm just going to do a SHA-512. Let's just check assembly. We have also have RISC-V torsion. Let's just see what the freaking RISC-V did. I'm gonna use I hope program is no. We just do here something here. I should put a RISC-V. This 5644.s, for example. This is RISC-V. How many instructions? 1,880, right? Let's just try Loongarch. They are GCC 13. Okay, I'm not using some old compiler. They're all GCC 13. I'm not using GCC, old GCC like the. What the fuck is that? Oh, ICE. We got ICE here. It's kind of ridiculous. It gets ICE. Report bug. Report bug. Open. What the fuck with this? What the fuck with that? It's definitely a bug in GCC. The report bug. Go bug 0. Let's just try another attempt. I don't know whether it's the issue with the GCC or on here or some else. Long arc 64. I'm gonna put long arc here. I don't know whether it's a front end or back end issues. More like a back end issues. But just put GCC. I don't care. Let them decide what's wrong with it, right? So they ask us to provide the pre-processed file. So when we report bugs, we better put what our flags here. Okay, just put all of them. Build should be x84 664 bound to Linux kernel. Host is x86 64 w64. Target long arc 64 Linux kernel. I guess it's not long arc's issue, it's the GCC's issue. Probably just recent days you have that issues here. What's the problem here? Unrecognized instruction. It's more like a backend issues here. Looks like we cannot do anything. It's still buggy. Let me try this on Linux. Try the program on Linux. It shouldn't, right? I mean, I think it's probably some instructions they don't recognize. Oh, no problem. Actually, no problem on Linux. Quite ridiculous. No problems on Linux, but some issues with Windows, right? So I guess it's something you know. Linux host, but crash on all Windows host. Okay, we put idea. Yeah, 120 200 2,267 instructions versus RISC-V. Dude, this is crazy. It's completely crazy, right? RISC-V is horrible architecture. it has nothing to do with 3D, right? That's graphic things that just deals with drivers, right? You have your drivers, and the driver will deal with that. The driver just follows the standards, provide the API. Now here you have, yeah. Now also, if you look at RISC-V, RISC-V is horrible if something like this. Even BiSwap, they need you to they need to put a function call here, BiSwap. Okay, BiSwap, dude. Just std BiSwap. They will put a intrinsic call here. So RISC-V is a very you can see why they are creating this new architecture, right? Even from instructions perspective, it makes sense. Because RISC-V is terrible architecture. I don't know what's the bug with it. I guess even native compiler has a bug. Even native compiler has a bug. I cannot open temporary file. It's a bug in the front end, in a fucking freaking front end. Whose bug? It should be the GCC front end bug. Dude, I think you should, yeah. Probably we're gonna call Jacob for doing that. I'm not gonna call them, just put here. Yeah. Yeah, it's a bug on the Windows, GCC bug on Windows, not the bugs on Linux. It's absolutely has nothing to do with target. I guess even get native compiler are gonna have the issue here. Well, I've said for China, they are doing that because they don't want to get controlled by United States. That's why they are doing that, The Loongarch was used, target audience was Chinese government. Yeah. Of course, they are all going to use x86, 64, right? What if United States blocks them for using x86, 64? But for RISC-V, a lot of people just say, hey, it's open, whatever nonsense, right? It's ridiculous. Can be ridiculous. Okay. It's upset this Chinese architecture. They are doing that because they don't want to get controlled by United States. That's why they are doing that, right? And then you might ask why they are not in RISC-V, because RISC-V instruction is not good. It's too fragmented. It's too fragile. They have this extension, that extension. You have to put a bunch of flags. And if you try to port your RISC-V programs, you're gonna be a huge trouble. You should use x86, dude. You should use x86 for PC. It's very good architecture, very good ISA. Don't listen to the people who hate x86. It's still a very good ISA. But actually, the important part, something quite interesting part is the Loongarch architecture provides extensions for x86 and ARM emulation. Okay, you can run not virtual machine. They have the instructions to run the x86 and ARM instructions. That's their extensions to allow the program running on the x86 mode, but using the Loongarch, using a Loongarch CPU. If you go here and we can go here, we see Loongarch document. They have the pages here. They have the documents. What about x86 64? I remember correctly, we have the x86. Yeah. In any case, it supports x86 binary translation extension, or they call it binary translation. So it can translate x86, translate ARM, translate MIPS. Okay, that and the ISA was designed in the way that just to make it easy to support this extension. So yeah, so this long arc ISA actually supports binary translation from to run x86. I guess that's what they are trying to do. But it's cool, but that doesn't mean it will work, right? If it really works and it could run very good, probably we're gonna see a huge something very big. But in reality, that doesn't happen, right? People would say, we did good things, but in reality, it's probably not going to that kind of easily happen. But we know the point of long arc isn't compared to RISC-V with some openers, whatever, or tutorial. No, long arc is mostly first to support the legacy MIPS binaries, porting legacy MIPS. Yeah. I don't know. I don't quite know. You should read their documents, right? Whether they support this, support that. They have the entire long song documents here. I can just put in the put here if you want to go here. Yeah. They have all the documents here. They also have a video. I just watched their videos. They're talking about long arc in Chinese, right? Because the Chinese architecture, I've said that. Yeah, this is a video about talking about that, but it's Chinese. They are saying they are supporting the thing here. I think there's something quite, yeah. They said they maintain the ecosystem of MIPS before. But you don't control MIPS, right? That's exactly why they are not going to continue using MIPS. They're just going to create their own ISA. The ABI is quite similar to RISC-V, I think. They don't have carry flags either. They don't have flags. The CPU itself, it doesn't have good. It's not quite good, but even with doing so, they just doing that. They find that they have the performance increase for 15 to 20%, but just by changing from MIPS to the long arc, the ISA. Yeah. This is they're talking about how they are going to just supporting x86. It is x86, right? Yeah. Just to support x86, they're gonna, if you have x86 moving instruction, you're gonna, that's what MIPS would do. But if they're using the long arc, the arc, they were doing the hardware acceleration, they would do something like this. They were just doing something like this. They did not need ISA to support. If we translate from x86, it should be a symbol. It should not generate too much instructions. Yeah. Finally they're going to do that, but in general you shouldn't do that much, right? If it's even Microsoft is doing something like binary translation from ARM. If this is going to be a thing, they can have a x86 subsystem that could run on long arc host Windows, run the x86 on the Windows here, on the long arc CPU, x86 program. At least that's their design. But I'm not a hardware expert. I don't actually know whether it could actually work. Was wondering if you, I don't quite understand what you're saying. What do you mean if you knew top of your head? Oh, yeah. This is not a tower, I say. They do have real world hardware of Longarch, yeah. But I don't think you can buy it outside China. I don't know. Okay. I create those compilers because I know there's a thing here. I want to just try those compilers, try to ensure my library could work, could port to these architectures. You know, the FastIO is super portable, right? Even works on this architecture. Because I will try to use all the cross compiler to ensure that it works. Okay, I can show you here what FastIO. FastIO actually have direct support for Longarch. Direct, you can see here Linux. Yeah, and this is RISC-V. Yeah, Longarch. Okay. Direct for ASM support, assembly support for the Longarch here. If we try to do something like file operations, let's just use FireIO, right? Let's see what the assembly is going to generate. I don't think it's going to generate. No, not this. Okay, this native compiler. I'm sorry. It's OFAS C++ 23 have homebrew one. Hope it doesn't crash. Oh, it doesn't crash. It crashed for SHA-512, but it doesn't crash for this program. Yeah, we should be able to see syscall instruction. Yeah. Okay, FastIO direct support for Longarch. The library supports those weird architecture directly by invoking syscalls directly. But I've never tested that. I don't know whether it works. Okay. I think it should have no problem. It shouldn't have any problems. Hey, let's just try Clan, whether Clan supports Longarch. I don't think it would support the triple, but we might be able to get it work. No, they don't have C++. No, we don't have. No, the triple. No, this triple. Triple equals. They don't have the triple, so still doesn't support this triple with probably because my client is a little bit old. I should upgrade it. Maybe it'll support that. But in general, that's the case. Yeah. Well, but you know, you're not just going to just get around all the issues by just designing ISA. That's just a step, right? You also have other problems like how to just create that chips. They have the technology to create that chips, no problem. But there's a lot of technology problems like for creating the high concentration CPUs, right? CPU cores. They don't have all the technology. They backs technology here. But maybe it will change in the future. At least they are not trying to do is that I'm going to targeting the party, the Communist Party, and the People's Liberation Army, right? So they at least they have the technology dependency if they have war with the United States. I think probably we're gonna have seen a war later. They won't have a technology gonna get blocked by technology, something like that. And yeah, it plays, at least currently it plays the role it plays. Yeah, if you wanna try that, you can go ahead and see the video. But if you don't know Chinese, you're not going to do that. I'm just gonna put a link here if you want to watch it. They are talking about why all it works. And they also talk about why RISC-V is not working. He's talking about RISC-V is basically university ISA. The universities, the professors love to use that. But it doesn't quite work well in the production. Both are imperialism. Imperialism always fight each other. If you really want to know why they are doing that, there's a very good video on why they are doing that. Okay, imperialism, right? Not imperialism, not this imperialism. Economies, Marxian economy. This is actually a video talking about why they are doing so. Okay, usually it's exactly why they are doing so, and I don't think it will change in the later future. Here, have imperialism. What's imperialism? International competition, colonialism, and imperialism, right? So yeah, if you wanna know the reason, you can go here and watch the freaking video. It will talk you. If the competition is so fierce, right? They will end up with a war. Maybe World War, right? Another World War with goods. But in general, the World War I and World War II are caused by the imperialist expansions, the imperialist interests, right? Basically, it's capital. And if you want to go and watch that entire economy videos on that, you can also watch other economy videos, whatever you want. Oh, right. Microeconomy, you can go watch that videos. If you want those economy things, but I don't think it's gonna, yeah. Yeah, you can. If you want to know why they are fighting, you can just go here and see the imperialism thing here. Imperialism. It was exactly like this 2011. If you just using that formula, you can see the history is basically repeating itself. Everything they said is happening. They said you have putting tariffs with each other. You searching for cheap labors, cheap resources. They are doing the same thing. And they kind of have war with it. Even you can even argue that the Russian invasion of Ukraine is another imperialist. It's basically imperialist competition. It's a proxy war between probably United States and China for the Russian invasion here. So if you want to go watch why they're doing that, you can go here. And I don't believe they are going to change, because the United States is facing a very fierce competition from China, right? From economy, from political, from geopolitics, right? It's not going to change very soon. That's why people are calling it a new Cold War, right? And yeah, we're not going to live in the past, like you have the globalization, everything is just globalized. It's probably going to end right now. Yeah, so this is why they are doing that, and why you need Canadian compiled log. Yeah, the Canadian compilation is very important if you really want to know C++. It's extremely important, because a lot of people, they are telling me they just cannot get a new compiler, right? They just cannot get a latest GCC to work. It's not easy, right? It's not trivial. Particularly Windows, they are running very old compiler, right? They just download a compiler. They don't know how to get a compiler on Windows could work. But with the Canadian compiler, you can just create a bunch of interesting toolchain, like DOS toolchain, FreeBSD toolchain. Okay, we also have FreeBSD toolchain. Yeah, I also have FreeBSD toolchain. Yeah, FreeBSD, cross-compiled FreeBSD programs on Windows. That kind of stuff. ARM, AX84. I also have ARM, no problem. I also have that. All sorts of compiler. That's quite important if you try to run on another machine. You don't actually want to install the compiler on the machine, right? You just want to compile programs, particularly with ARM, right? ARM is just Raspberry. I have Raspberry I can show you here. Now, this is a Raspberry, right? Now this Canadian compilation, it's not. I'm just bootstrapping the compiler itself on the ARM because it's very slow. The machine is very slow, right? Yeah. Let me just try. Yeah. For example, I can show you here. Try whatever example. Try my favorite example. Like this example. Construct f-string from syscall. F use ld equals go. We can use go linker here. Construct f-string from syscall. Yeah, we compile the ARM programs on Windows with Linux. Construct f-string from syscall. Yeah. Now we can use ARC64 Linux. No, just LVM obj down to see the binary here. Yeah. Yeah, always do that. Oh no, this is x86 one. The ARM machine is here. Yeah, you also do that. Just delete them. Yeah. Okay. This cross compiled from Windows to ARM. Nice. It's just, I mean, a lot of issues. If you don't do Canadian compilation, you're gonna have all sorts of libraries. This depends on that. This break ABI break. This one, that one, right? You probably also wanna do that on Windows, because you can test both on Windows and Linux with MSVC and on Linux. Yeah. Also, this could also work. Yeah. x86-64 Linux kernel. And if you're trying to do x86-64 16 kernel, we can actually do mark equals native. Okay, not x86. I differentiate that. I just put a Ubuntu here. Yeah. Yeah, now we create what the binary we create is x86-64 Linux kernel. I don't know why the binary is so big with the probably because the linker issue. Yeah. Yeah. This was on x86, right? Just cross-compile Linux programs on Windows, right? People would never do that, right? You never heard anyone saying, "Hey, let's just cross-compile Linux program on Windows." Particularly cross-compile to x86-64, right? You never heard of that. Nobody is doing that, right? But I'm just creating that compilers because I need it a lot. I find it quite important, very important to do so. It's much important than a lot of other toolchains. Because I frequently what I need is like changing some coding fast.io. Then I don't want to just, hey, I just go another machine or go WSL or whatever to compile it again. I just use this cross compiler to get it work, right? Just get the Linux programs compiled and run on the machine. On Windows compiled and put it on Linux. Yeah. So I think it's quite long. It's nearly 2 hours. Thank you for watching. If you have questions, you can just ask all the questions in the Discord. Okay. Bye.